Welcome everybody once again. So in today's class, let us solve a few problems on flow through pipes. Let us see the problems on losses through pipes. Okay, as we discussed in the last class, we are considering the losses due to friction. So due to friction means that is major losses, and there are other minor losses due to the expansion of pipe, contraction of pipe, obstructions in the pipe, etc. So we will analyze a few problems related to these major losses and minor losses. So the first problem is find the head lost due to friction in a pipe of diameter 30 centimeter and length 50 centimeter through which water is flowing at a velocity of 3 meter per second. Using Darcy's formula and Chezy's formula, for which C is Chezy's constant, C equal to 60. Take nu for water is equal to 0.01 stoke. So what is mean by nu? We have studied in our first module, nu means kinematic viscosity. Okay, now see, find the head loss due to friction in a pipe of diameter 30 centimeter. So we will draw a pipe of diameter 30 centimeter. So this pipe, the diameter of the pipe is 30 centimeter, that is equal to 0.3 meter. The length of the pipe is 50 meter. So the length of the pipe is given as 50 meter. So we will take the diameter of the pipe as small d. So diameter of pipe small d is equal to 30 centimeter, that is equal to 0.3 meter. The length of pipe L is given as 50 meter. Through which water is flowing. So the flowing liquid is water and the water is flowing with a velocity of 3 meter per second. So velocity of flow, mean velocity of a flow, V equal to 3 meter per second. So we have converted everything in terms of meter, right? Now, the Chezy's constant is given as C is Chezy's constant. Okay. So Chezy's constant C is equal to 60 and nu is nothing but kinematic viscosity. Kinematic viscosity nu is given as 0.01 stoke. So if it is 0.01 stoke, that is nothing but stoke. 1 stoke is equal to, we have studied in our first module, 1 stoke is equal to 1 centimeter square per second. So it is nothing but 0.01 centimeter square per second. So converting it into meter square per second, we get 0.01 into 10 raised to minus 4 or divided by 10 raised to 4 meter square per second. Now what we need to find? We need to find the head lost. We need to find what is HC. We need to find what is HC. So we have to use these two formula. First is Darcy's formula and the second one is Chezy's formula. So first of all, we will use Darcy's formula. So first case, we use Darcy's formula. So we know Darcy's formula for head loss is given by HF is equal to, that is head loss due to friction. H means head loss, F means friction. This is major loss. So for major losses, we have two formula. To determine the major loss, we have two formula, Darcy's formula and Chezy's formula. So Darcy's formula is HF is equal to 4FLV square by 2GD. Now, we know L, V is known for us, G is 9.81 and the diameter is also given. The only unknown is F. So F is nothing but the coefficient of friction. So we know we have already studied coefficient of friction depends on the Reynolds number. Okay, so first of all, we should find what is the Reynolds number. So we know coefficient of friction. Okay, right. So in order to find the coefficient of friction, we will find the Reynolds number. We know Reynolds number is equal to V d by nu. That is nothing but V d by rho V d by mu. If it is dynamic viscosity. Now it is given as kinematic viscosity. So V d by nu. So that is equal to V velocity is given as 3 meter per second. Diameter of the pipe is given as 0.3 divided by nu is given as 0.01 into 10 to the power of minus 4. So from which we get the Reynolds number is equal to 9 into 10 to the power of 5. Okay. So now we will find the coefficient of friction F. So coefficient of friction is equal to. So if it is 9 into 10 to the power of 5, this means the flow is turbulent. So we know we have two formula for finding the coefficient of friction. So F is equal to 16 by Reynolds number if the Reynolds number is less than 2000. And the coefficient of friction is equal to 0.079 by Re raised to 1 by 4 if the Reynolds number is greater than 4000. So here it is greater than 4000, which means the flow is turbulent. If the flow is turbulent, we have to use this formula. So F is equal to 0.079 divided by Reynolds number raised to 1 by 4. So we get 0.079 divided by 9 into 10 raised to 5, the whole power 1 by 4. That is equal to 0.00256. So the remaining variables are known for us. So we will substitute in the formula. We get HF is equal to 4 into the value for F is 0.00256 multiplied by length is 50 meter multiplied by V square. Velocity, mean velocity is 3 meter per second. So it is 3 square divided by 2 into G is 9.81 multiplied by the diameter of the pipe is given as 0.3 meter. So 0.3 we get the head lost due to friction by using Darcy's formula as 0.7828 meter. Now we will move on to the second subtitle, that is using Chezy's formula. So how will we determine the head loss using Chezy's formula? C is given as 60. So case 2, second case is using Chezy's formula. Now we know the Chezy's formula for velocity, that is V is equal to C into root of mi. Now mean velocity is known for us. Chezy's constant C is given as 60. And the pipe is a circular pipe. The cross section of the pipe is a circular pipe, which means M is equal to A by P. Wetted area by perimeter is equal to D by 4. We have already studied in our last class, M is equal to wetted area by perimeter. Area is pi d square by 4. Perimeter is pi d. So we get pi get cancelled. This get cancelled. We get d by 4. So m is equal to d by 4. Right? Diameter by 4. So from that we can find what is I. So from this formula, from this we get the velocity is given as, mean velocity is given as 3 meter per second. That is equal to, Chezy's constant is given as 60 into square root of m. M is nothing but hydraulic mean depth. Okay, so I'll write here. So hydraulic mean depth, m is equal to wetted area by perimeter. So wetted area is pi d square by 4. Perimeter is pi d. So from which we get mean hydraulic mean depth, m is equal to d by 4 if the cross section is a circular. So m is d by 4. The diameter of the pipe is 0.3. So 0.3 by 4 into I. So I is the hydraulic gradient, from which we get I is equal to 0.0333. And we know I is equal to hydraulic gradient, that is nothing but the head loss due to friction divided by L, H by L. That is hydraulic gradient. So from which the only unknown is HF. So HF is equal to L into I. So from which we get HF is equal to, the length of the pipe is given as 50 meter. I is the hydraulic gradient. We have found it as 0.0333. From which we get the head lost due to friction using Chezy's formula as 1.665 meter. Okay, so comparing both, the head lost is more in the case of Chezy's formula, and this depends upon the Chezy's constant also. Now we will move on to the next problem. The next problem is, find the diameter of a pipe of length 2000 meter. So the length of the pipe is 2000 meter. We are asked to find the diameter of the pipe. When the rate of flow of water through the pipe is 200 liters per second. That means the discharge is 200 liters per second. So discharge Q is equal to 200 liters per second. So converting it into meter cube per second, we get 0.2 meter cube per second. Divided by 1000, we get 0.2 meter cube per second. Because 1 meter cube is equal to 1000 liters. Okay, so in order to convert liters to meter cube, we divide it by 1000. Now, and the head lost due to friction is 4 meter. So HF is given as 4 meter. The value of Chezy's constant C is given as 50. So how will we find the diameter? Okay, we know the formula for Chezy's constant is V is equal to C into root of Mi. And since the cross section is circular, you are asked to find the diameter, that is C into root of M is D by 4 into I. M is D by 4. Okay, now how will we determine this velocity? So velocity, we know discharge is equal to area into mean velocity. So from which we get velocity is equal to discharge by area. Now what is discharge? It is given as 0.2 meter cube per second. divided by area is pi d square by 4. Okay. Now we know hydraulic mean depth is d by 4. And what is I? I is equal to hydraulic gradient hf by L. Now what is hf? hf is given as 4 meter. So 4 meter divided by length of the pipe is given as 2000. So 4 by 2000, it is a 0.002 is I. Now we will use the Chezy's formula, that is V is equal to this formula, C into square root of D by 4 into I. The value for C is given as 50. So we will write the formula C into D by 4 into I. So we have determined V as 0.2 into 4 divided by pi d square. That means 0.8 divided by pi d square is equal to value of C is given as 50 into square root of d by 4 into I. I is given as 0.002, from which the only unknown is d. We get d is equal to 55.3 centimeter. So this is the diameter of the pipe. We will move on to the third problem. So third problem is an oil of specific gravity 0.9 and viscosity 0.06 poise. Here viscosity is given in poise. That means it is dynamic viscosity. Poise means it is dynamic viscosity. Stoke means kinematic viscosity. Okay. So an oil of specific gravity 0.9 and viscosity 0.06 poise is flowing through a pipe of diameter 20 centimeter. 20 centimeter, that is nothing but 0.2 meter. So specific gravity, so the flowing liquid is oil. Specific gravity of the oil is given as 0.9. The dynamic viscosity is represented by mu. Okay, it is dynamic viscosity. So mu is equal to 0.06 poise. So converting it into Newton second per meter square, we have to divide it by 10. See, these things we have studied it in our first module, the conversion and everything. So 0.06 divided by 10 Newton second per meter square. The diameter of the pipe is given as 20 centimeter, that is equal to 0.2 meter. Now it is flowing at a rate of 60 liters per second. That means Q is equal to 60 liters per second. Converting it into meter cube per second, we have to divide it by 1000. So we get 0.06 meter cube per second. Find the head loss due to friction. We need to find what is the head loss due to friction for a 500 meter length. So length of the pipe is 500 meter. Find the power required to maintain this flow. And what is the power required to maintain this flow? This is our problem. Now, we will apply Darcy's equation, Darcy-Weibach equation. Okay. So now we know Darcy's Weibach equation is HF is equal to, because Chezy's constant is not given here. So we will use Darcy-Weibach equation. So we know Darcy-Weibach equation is HF is equal to 4FLV square by 2GD. So 4 is constant. F is coefficient due to friction. So first of all, we will find what is F. Now, in order to find F, we know F depends on Reynolds number. So for that, we need to find Reynolds number first. So what is Reynolds number? Reynolds number is equal to rho Vd by mu. So that is nothing but Vd by nu. Nu means kinematic viscosity. Kinematic viscosity nu is equal to mu by rho. Dynamic viscosity by rho. We have studied these in our first module. Okay. So, here we will directly apply because dynamic viscosity is given rho v d by mu. So, rho is density. It is the flowing liquid is oil. So, the specific gravity of the oil is 0.9. That means the density of the oil is 0.9 into 1000. Right? Because the specific gravity is equal to density. If a specific gravity of the oil is equal to density of the oil divided by density of the standard liquid, that is water. We know density of water is 1000. So, density of oil will be equal to specific gravity into 1000. So, it is 0.9 into 1000. Multiplied by velocity. Oh, we don't know velocity, right? So, we will find velocity also. Now, we know discharge is equal to velocity into area. So, velocity is equal to discharge divided by area, which is equal to discharge is 0.06 divided by area is pi d square by 4. Pi into d is 0.2 square divided by 4. We get the velocity as 1.91 meter per second. Okay, so rho is 0.9 into 1000. Velocity is 1.91 multiplied by diameter of the pipe is 0.2 divided by mu. Dynamic viscosity is given as 0.06 divided by 10. 0.006. We will write 0.006. So, we get the Reynolds number as 57,300. If the Reynolds number is greater than 4000, so this is greater than 4000. So, if Reynolds number is greater than 4000, the coefficient of friction F is equal to 0.079 divided by Re raised to 1 by 4. So, from which we get F is equal to 0.079 divided by Reynolds number is 57,300, the whole raised to 1 by 4. We get coefficient of friction as 0.0051. Now, we will apply the coefficient of friction in our formula. So, our formula is HF is equal to 4FLV square by 2GD. See, what I have found is, I have found what is coefficient of friction. What is velocity? You write the formula, check what are the unknowns, find the unknowns, substitute in the formula. So, we get 4 into F is 0.0051 multiplied by length of the pipe is 500 multiplied by velocity is 1.91 square divided by 2 into gravity is 9.81 multiplied by the diameter is 0.2. We get HF is equal to 9.48 meters. So, this is 9.48 meter of water. Okay, you have to express it in terms of water. Now, the power required. So, what will be the power required? We are also asked to find the power required to maintain this flow. So, what will be the power required to maintain the flow? So, the formula is, the formula for power required to maintain the flow. Formula is equal to rho G Q H F by 1000 in order to convert watts into kilowatts. See, this divided by 1000 is for converting it into kilowatts. If you are expressing it in watts, it is rho G Q into HF. Okay, rho into G. See, rho into G is nothing but, this rho G is nothing but the weight density. So, weight density into discharge into head loss. Okay, that is power required. Weight density multiplied by discharge multiplied by head loss. That is the power required to maintain the flow. Okay, that means the weight density into head loss times the discharge. So, expressing the weight density is equal to mass density into G. We get rho G Q HF. So, we get density is 900, 1000 into 0.9, right? I have explained to us earlier, density for oil 1000 into 0.9 because specific gravity is 0.9 into 9.81 into the discharge is 0.06 into head loss is 9.48 meters divided by 1000. If you are expressing in watts, this 1000 is not needed. So, that is equal to 5.02 kilowatts. For expressing in kilowatts, you have to divide it by 1000. We will move on to the next problem, fourth problem. So, the fourth problem is find the loss of head when a pipe of diameter 20 centimeter is suddenly enlarged to a diameter of 40 centimeter. The rate of flow of water through the pipe is 250 liters per second. Okay, so the diameter of the pipe is given as 20 centimeter, that is equal to 0.2 meter. So diameter is given as 20 centimeter, that is nothing but 0.2 meter. It is suddenly enlarged to a diameter of 40 centimeter. Okay, so this 20 centimeter pipe is enlarged suddenly to a diameter of 40 centimeter. So here diameter 2, we will take this as diameter 1. So diameter 2 is 40 centimeter, that is equal to 0.4 meter. So D2 is equal to 40 centimeter, that is equal to 0.4 meter. The rate of flow of water through the pipe Q is equal to 250 liters per second. Converting it into meter cube per second, you have to divide it by 1000. So 0.25 meter cube per second. We are asked to find the loss of head. See, since it is enlargement, the loss is due to the enlargement of the pipe. So it is minor loss. Now, we know the formula for the loss of head due to enlargement. So loss of head due to enlargement, HE. We will write loss of head due to enlargement, HE is equal to V1 minus V2 the whole square by 2G. So now we need to find what is V1 and what is V2. For that we will apply the continuity equation. We will take this as section 1, this as section 2, and we will apply continuity equation. We know the continuity equation as Q is equal to A1 V1 is equal to A2 V2. So Q discharges 0.25 is equal to A1 pi D1 square by 4 into V1 is equal to pi D2 square by 4 into V2. Therefore, 0.25 is equal to pi into D1 is 0.2 square by 4 into V1 is equal to pi into D2 is 0.4 square by 4 into V2. Now, we can equate these both. We can find what is V1. Equate these both. We can find what is V2. So, equating these both, we get V1 is equal to 7.96 meter per second and V2 is equal to 1.99 meter per second. So, after finding V1 and V2, we can substitute in the formula. So, we get head loss due to enlargement H is equal to V1 is 7.96 minus V2 is 1.99 the whole square divided by 2 into 9.81. So that is equal to 1.816 meter of water. We will move on to the next problem. So next problem is, at a sudden enlargement of water main from 240 mm to 480 mm diameter. Okay, so there is a sudden enlargement of main. So the enlargement is from diameter is equal to 240 mm to 480 mm. So here the diameter we can take it as D1 and D2. D1 is 0.24 meter and D2 is 0.48 meter. Okay, so D1 is equal to 240 mm, that is equal to 0.24 meter, and D2 is equal to 480 mm, that is equal to 0.48 meter. Now, the hydraulic gradient rises by 10 mm. Now, what is hydraulic gradient? We have already studied in our last class about hydraulic gradient line and total energy line. So, what is hydraulic gradient line? The line joining the hydraulic gradients. So, hydraulic gradient is equal to pressure head plus datum head. So, pressure head is P by rho G, datum head is Z. Total energy is equal to pressure head plus velocity head plus datum head, that is P by rho G plus V square by 2G plus Z. Now, it is given as hydraulic gradient rises by 10 mm. So, hydraulic gradient is nothing but P by rho G plus Z. So, P by rho G plus Z of 1 is the hydraulic gradient for the section 1 minus P by rho G plus Z of 2, that is hydraulic gradient for pressure 2 is equal to 10 mm, that is equal to 0.01 meter. That is the meaning of that. Okay. So now we have to estimate the rate of flow. What is Q? That is our question. So how will we write this? So I hope you understood the concept hydraulic gradient line and the total energy line. We have studied it in our last class in the theory part. Okay, now in this question it is given as the hydraulic gradient rises by 10 mm. So if the hydraulic gradient rises by 10 mm, we have two sections. We can take this as a section 1 and this as section 2. So if the hydraulic gradient is rising, it is P1 by rho g plus Z1 minus P2 by rho g plus Z2 is equal to 10 mm, that is equal to 0.01 meter. Now, here there is a sudden enlargement. So, if there is a sudden enlargement, we know the formula for head loss due to sudden enlargement is H is equal to V1 square minus V2 square by 2G. So, that means V1 square by 2G minus V2 square by 2G. Now we will apply Bernoulli's equation at section 1 and section 2. So apply Bernoulli's equation. We know P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2 plus losses. Here the losses is due to enlargement, so it is He. Now we can rearrange this. We get P1 by rho G plus Z1 minus P2 by rho G plus Z2 is equal to V1 V2 square by 2G minus V1 square by 2G plus He. Now we can apply the continuity equation. Applying continuity equation, space is okay. Listen, applying continuity equation, we get Q is equal to A1 V1 is equal to A2 V2. See, since we don't have enough space here, I am trying to write here. So that is why I have used another color. Please adjust. Okay. So here we know we are going, what our aim is to write velocity V1. We are going to relate these both. We are going to write V1 in terms of V2. So V1 is equal to A2 V2 by A1. So that is equal to, what is A2? Pi into D2 square by 4. A1 is pi into D1 square by 4. You substitute D1 is equal to 0.24 and D2 is equal to 0.4, right? We get V1 is equal to 4 times V2. V1 is equal to 4 times V2. I repeat. So from these continuity equation, you get V1 is equal to A2 V2 by A1. For A2, you use the formula pi D2 square by 4. For A1, we can use pi D1 square by 4. So for D2, you substitute 0.48 meter, and for D1, you can substitute 0.24 meter. We get V1 is equal to 4 times V2. Now, we can find what is He. Substitute this. We will take this equation as 1. Okay, substitute this value in equation 1. We get He is equal to V1 is 4V2, right? 4v2 the whole square by 2g minus v2 square by 2g. So we get HE is equal to 9v2 square by 2g. Now we will substitute this value of HE. We will substitute this value in equation number 2. We will take this Bernoulli's equation as equation number 2. Okay, we will take this as equation number 2. So our equation number 2, we have already found P1 by rho g plus Z1 minus P2 by rho g plus Z2 is 0.01 meter. So this is equal to 0.01. 0.01 is equal to V2 square by 2g, V2 square by 2g. G is 9.81 minus V1. V1 is 4 times V2. 4 times V2 square by 2g. Sorry, 4 times V2 the whole square. 4 times V2 the whole square by 2g. 2 into 9.81 plus HE, we have already obtained it as 9V2 square by 2g. So the only unknown is V2, from which we get V2 is equal to 0.181 meter per second. So if V2 is equal to 0.181 meter per second, we know Q is equal to A2V2. So you can substitute Q is equal to A2V2 is equal to pi d2 square by 4 into V2 is 0.181. We get Q is equal to d2 is 0.48. We get Q is equal to 32.75 liters per second. See, you have to, after seeing the problem, you have to understand the problem, try to draw the diagram, write all the possible equations, you will get the answer. Okay, don't get confused, don't get tensed. So cool down, understand the problem, understand the concept, write all the equations, you will get the answer. We will move on to the next problem. Next problem is the rate of flow of water. So I think it is enough for today. The remaining problems we will continue in the next class. Thank you for today.